This video is going to look at axial symmetry and central symmetry. So first we need to understand, what does symmetry actually mean? And what symmetry means is that we can reflect things so that they have another kind of being on another side of something. So we'll talk about different types of axes of symmetry. So let's just look at a very simple one, the letter, or a square, sorry, we'll look at a square first, okay? So we have to ask the question, how many axes of symmetry are there? So as in, where can I fold this in half that it'll be exactly the same? So obviously we have one down the middle here, where we can fold this in half. We have one across here, because we can fold this in half. And we also have the corners, right? So there's our axes of symmetry. We've got 1, 2, 3, and 4 is down here. So that's how we look at different axes of symmetry. Everything, well, not everything has an axis of symmetry. Some things are symmetrical, some things aren't. But we can look at that by looking at a few letters. So B, if I drew it nicely, has one axis of symmetry through the middle, where we can flip it and it looks the same. H has 2, obviously through the middle here, and also down here. And finally P. P doesn't have any axis of symmetry, because if I cut it anywhere, it's never going to fold exactly in half. Okay. So now, if I was to give you an image of an object, let's say, so that's our axes of symmetry. It's important to understand that some objects have symmetries and some don't. And now if we were asked to reflect an image over an axis, so say we had this letter, sorry, this is really badly drawn, but F, okay? And we had something called this axis, right? It's just like a line that we're gonna work around. And I want you to reflect over this axis. So if we were to make this like a mirror, it would just flip over like this, right? So we're gonna do that. The best thing first to do, that I always do, is mark all of our points. So these are our main points. There's here and here, but you also have to make sure here's a little edge, so we make this a point as well. I'm going to call it A, B, C, D, and E. Okay. I'm going to take my ruler here, and if you're doing this on square paper, it's probably a lot easier, but I don't have any square paper right now, so we're going to do it like this. And we measure the distance from the point A to the axis, which is 5 centimeters, and then we keep that in line, and measure out another 5. So we go out to 10, and that's going to be our A. Now when we're drawing our A, we go A dash. Now B, we do the same, so it's just about over 2, so it'll be just over 4. We do a little dot there, and we call this B dash. Next one we do is C. So as you can see, it's pretty straightforward. 4.5, so it means it's going to be 9. Sorry, I'll keep it on there so I can see everything. It's going to be 9. Now my drawing isn't very straight, as you can see, but for the purposes of this, you can understand. And this will go to 5. That's be D dash. And finally, E goes 4.5, so E is going to be 9 over. Okay. So now all we have to do is, this is something where people will start crossing things and everything. A goes to B, so make sure you know where the line or where the points connect. So A goes to B, A goes to C, C goes to E, and C goes to D. Now, as you can see, mine is not super accurate. It's all kind of all over the place, but that's because of the way I've drawn this and not used square paper. So that's a really important thing, to make sure you use square paper all the time, because you can end up with something that is slightly not right. But as you can see, it's pretty, it's basically just a flipped over. So if we fold the paper in half, you would end up with this on the other side. Imagine if you're painting along here, leave a load of wet paint, and then folding it in half exactly, you would end up with this. So that's axial symmetry. Another type of thing that they can ask you, just to so you don't forget, is from our coordinate geometry. You could be asked something where it's on the x and y axis. So just imagine that we had, I don't know, some shape here, some triangle. Okay, and let's say this 1, 2, 3, 4, 5, minus 1, minus 2, minus 3, minus 4, minus 5. Okay, and then we've got 1, 2, 3, 4. That's how much we need to go. So you could have something like this where it'll say reflect this image on the y axis. And what it means by y-axis is it means that we want to put it on the other side of the y-axis. If it said the x-axis, we'd flip it down to here, okay? Or it can ask you to go through a point in the middle, and that's what the next video is going to be about. Or no, this is what the next section is going to be about, sorry, which is central symmetry. So it could ask us to go through a certain point. So just remember that y-axis and x-axis can come into play in this, so we might have to reflect it over here or down here. But now let's look at what's called central symmetry. Okay, so central symmetry is reflecting something through a point. Okay, so let's take that example of the F again, the letter F. A, B, C, D, and E. I'll make this a little bit longer. Okay, so there's our thing, and we're going to have a point here called O. And it's going to ask you to reflect this image through the point O. So what does that mean? All that means is we have to take our ruler, we have to measure the distance exactly through this point. So as we know from our coordinate geometry and our geometry even, that we can't have, there's no two lines that go through 2 points. So if you think about it, we've got B and O, so there's always going to be only one line that goes through both of those. So we measure from here, and I always like, let me get a pencil really quick. I always like to do a little dotted line with my pencil from here to here. I find this the easiest. So we get to 6.5 here, so that means we're going to go to 13 over here. And I'm going to do a little pencil dot there. And let's do that for every single one. So it takes a little bit of time, this is 7.5, so it's going to be 15 on the other side. So you're just measuring the distance to that point and then doing the same distance again over to the other side. And where's the next one? Our next one is C. C is 6 centimeters away, so we're going to have to do 12. D is 4 centimeters, so it's going to be 8. And E is how much? Just over 5, so just over 10 then. 10 and a bit. Okay, there's that. So now let's make sure that we've marked all our points, which I haven't done, which was a bit silly of me. So looking at B, B went down to here, so we call that B dash. A went over here, A dash. I'm just going to check my A again because it doesn't look perfect. 7.5 should get to 15. Nope, it's okay. C goes to 12, yeah. C dash. This one here is D dash, and this is E dash. And then again, like our previous example, we just need to join up the dots. So A to B, C, F. There we go. And there we have an F. So as you can see, it's kind of turned itself upside down and gone that way because it's gone through this point. So it's kind of gone around here. And that's your central symmetry. It'll always make it look really kind of weird. It'll be flipped over and turned upside down. So that's our two ways of figuring out the differences between the two symmetries. So we've got axial symmetry. Axial means we'll just say flipped over, right? And I'll give you the example of F becomes F, or remember that we can have it the other way. We can have it over here. And if we were to flip that down here, we'd end up with this, okay? It's like a mirror. And then central is flipped and upside down. So that would be this becomes this. And it's always through some point, okay? Through some point. Central symmetry means it can go through a point to another place. So that's basically central symmetry and axial symmetry. It's something that you just have to practice and make sure you're accurate with your pencil and your pen and your ruler. The other thing is, if you're trying to do it on square paper, obviously, because it's a lot easier. You can just count the squares between things and it'll be a lot easier. The next video will be on how to do a translation and a rotation of an object.